Papa Radio PUR6, 47S, 1947 or later. This is the documentation of the experience of a hobby project, made with the hope that it could be helpful to others. However, these videos are not intended as tutorials. They only show the development of a personal practice, which may or may not be a good one. Therefore, if you are following along, you are doing so at your own risk. This is a French radio that very likely was made in the late 1940s or early 1950s with an unknown brand name, Papa Radio. The model name appearing in the plate riveted on the back of the chassis may suggest that this is a sixth model, and the number 47 may refer to the development year. The radio came from France with no tubes except for the Magic Eye, which was already completely dark and with no loudspeaker and final audio transformer. The previous owner explained that he sold the tubes, but that he could not remember anything about the missing loudspeaker. Unfortunately, the dial glass arrived broken due to the shipment. Observing later the RF module and the IF transformers, they appear to be very cheap parts. Considering that they are the most important components in a radio, the whole set must have been cheap. It could have been a kit, but the seller is sure that the original owner, his grandfather, would not have built it. Therefore, Papa Radio, which today remains an unknown brand, must have been a small-scale artisanal production. Before throwing away the remains of the packaging, under the circumstances, it is advisable to make sure to have all the small pieces of the dial glass. They are carefully collected, ordered, and temporarily attached together using transparent adhesive tape. While doing so, one is obliged to pay attention to the writings, and some details become interesting. On the left side appears this annotation which tells who printed the dial glass and the serial number of this particular design. In particular, the plan was made according to the reception from the area of Cairo City. A big piece of glass is missing, because that is the only portion that is still on the dial panel. When everything is arranged properly, it can be scanned. Then, using a vector graphics editor, the dial scale is redrawn, and finally it is ready for printing it again on a piece of acrylic glass. Like for other projects of this series, the written documentation that comes along with this video includes a better detailed picture of the redrawn dial glass. These two clips are meant to show the initial condition of the unit above and under the chassis. The lack of information regarding the design of this radio requires reverse engineering the schematic diagram, also making the necessary guesses over the missing parts and the possible set of tubes. This process starts by carefully observing the chassis and writing down a draft schematic diagram and a map of components under the chassis. Then, when a first draft is made, it is possible to start dismantling and cataloging the component, correcting the drafts when necessary. This process must be extremely careful, and it can only be very slow. Therefore, these clips are very accelerated, and without further comments, they will reach the point of a chassis reduced to the bare metal. The chassis is slightly deformed on one corner, but that is easily fixed using pliers. The rust requires more important attention instead. The bare chassis metal is put in a plastic container and later submerged in some diluted vinegar with the purpose of dissolving the rust. The dilution is necessary because the available vinegar would be otherwise insufficient for covering completely the chassis metal. The vinegar dilution makes the process slower. Therefore, only after a few days the chassis is extracted from the acid bath and washed carefully, and then also cleaned from previous paint residues using acetone. Finally, it is immediately sprayed with zinc paint. Later, a fair amount of ground soldering points are prepared using a powerful soldering iron. The power transformer is cleaned, initially using an air blower. The voltage selector jumper is removed. One should know that on French radios, this jumper is typically used also as a fuse connecting the two terminals with fusible wire. The cleaning process continues with alcohol and cotton balls. The rods that keep together the transformer structure are removed. They have a thread that is not standard nowadays, but that will be discovered only later when they will be replaced with new M3 rods. The input voltage selector structure is removed by desoldering all the primary winding taps. The original insulation for these wires is now rotten, and it is replaced with white heath shrink pipe. However, only the inputs for 220 and 245 volts are left accessible. All the others are insulated completely after making sure that the primary winding remains continuous. Testing the output voltages and the temperature of the transformer, although without load, the result is satisfactory. The metal spacers that hold the phenolic board used for the voltage selection are treated with a gel rust remover. Later they are washed with alcohol, and the phenolic board is cleaned as well. Unfortunately, alcohol also erases the white writings on the phenolic board. The transformer is masked so that the laminations can be spray painted. The next day, the masking tape is removed and the transformer can be rebuilt. The plan would be to reuse the original brass cup nuts, only later it will be apparent that they are not threaded M3 like the new rods, and then they will have to be replaced with regular M3 nuts. To avoid eddy currents crossing the laminations, the rods are insulated using heath shrink pipe. Later, nylon washers will be used to avoid also the chance of contact between the most external laminations. The brass cup nuts with incompatible thread are replaced with regular M3 nuts, and then the transformer is rebuilt using the new rods. At the moment, only the primary winding taps for 220 and 245 volts are soldered to the voltage selection board. Later, only the 245 volts input would be effective. The transformer is tested again, just to verify if so far everything has been done correctly. Before cleaning the variable capacitor, it is necessary to remove the other components and the wires that are still attached to it. It is also useful to remove the excesses of solder residues. There is a lot of rust on this variable capacitor, which also affected the trimmers on top. A gel rust remover is used to dissolve as much of it as possible. A little while after the application, the residues are washed using alcohol and then dried with an air blower. Alcohol does not dissolve all the components of the rust remover, but it makes them almost completely ineffective. Then, with the help of a clean paint brush, some cotton balls, and more alcohol, all the residues that are still visible can be removed. The trimmers on top are dismantled so that the internal surfaces become accessible for further cleaning. All the small parts of the trimmer capacitors are cleaned individually using the same products. The variable capacitor is washed with alcohol and dried with the air blower one more time before reassembling the trimmers. Some Vaseline oil is put on the bearings, on the contacts, and on the surfaces that were originally corroded. The trimmer capacitors are reassembled. Some Vaseline grease is added to the bearings. The RF coil pack with trimmers, called here just RF module for short, is the real sore point of the restoration. This component is compact, fragile, and cheap. It contains an intricate wiring made of extremely thin and almost invisible Litz wire. It hides unsealed mica capacitors that must be replaced because they are now affected by silver mica disease. It only allows the adjustment of the local oscillator frequency, with no padding and with no provision for an alignment of the antenna section. In other words, it is almost impossible to make the antenna and the oscillator section track properly on each band. Initially, some Vaseline oil is applied to the contacts and corroded metal parts using a tiny paintbrush. This also with the purpose of familiarizing with the module. On a general-purpose chassis for experiments, a typical radio circuit is built, from the antenna to the first IF transformer, using an external power supply. This is done for checking if the RF module is still capable of working. The original mica capacitors are still there, but the oscillator section is still capable of working, which encourages in proceeding with the restoration of this component. It is necessary to remove the metal bracket that hosts the trimmer capacitors in order to access the space inside the module, but that requires to separate some connections. The deteriorated mica capacitors are replaced with NP0 style equivalents to avoid drifting in the reception. However, they are SMD components and some adaptation is required before installing them in a point-to-point circuit. As an exception to the choice of NP0 components, this one is a ceramic safety capacitor for keeping the module isolated from the antenna input. When it is time to reinstall the bracket, it is observed that one trimmer, precisely the one responsible for adjusting the oscillator frequency in the medium wave band, is broken and cannot be fixed. Therefore, it is removed and a new trimmer capacitor is adapted, but in a different location. The bracket is installed in its position, but slightly more spaced, to allow the remaining two trimmers to be operated without fearing to touch the delicate coils underneath. This is the new trimmer for the medium wave band. Later it will be necessary to increase the minimum value, adding in parallel a fixed capacitor. Both IF transformers arrived severely damaged, very likely due to the shipment and the quality of the fragile plastic used to hold the stem of the coils. Before doing anything else, they must be dismantled completely. Later they could be rebuilt. At this stage, special care should be given to the coils. They need to be rewound, keeping the loose wire in place with the help of some wax. The ceramic element on top, holding the two trimmer capacitors used for the alignment to the intermediate frequency, are cleaned using alcohol. On both IF transformers, the trimmers were squashed completely, and even removing the screws, they remain flat and not adjustable anymore. After cleaning also the elements of the trimmer capacitors, an attempt is made to fix the blades by bending them slightly. After rebuilding one of the trimmers, it is tested to evaluate the interval of capacitance that it can be adjusted to. Unfortunately, that interval is insufficient and new and more effective trimmers should be installed. The new trimmer capacitors are installed on top of the original ceramic bases, but because they remain somehow loose, some hot glue is used so that they would not move while adjusting them. Before rebuilding the IF transformers, the inductance of the coils is measured. It turns out that the first IF transformer has coils with a higher impedance compared to the second. The IF transformers are rebuilt, starting from the internal stem, which now is a nylon M4 threaded rod. Once the coils are connected correctly, it is a good idea to use more wax to cover the Litz wire, especially where some of the delicate copper remains exposed. This is the first IF transformer, which requires a connection to the top cap of the IF amplifier tube. On top of the ceramic base, two spacers are needed to avoid the contact between the trimmer capacitors and the metal IF can, due to the presence of new trimmer capacitors which occupy more space. New and taller nylon spacers are used. The aluminum IF cans are polished using a metal polish product and steel wool. One of the two trimmer capacitors is connected to B+. Therefore, it seems a good idea to isolate the holes used for accessing the trimmers with grommets, in case one decides to do the adjustment using a non-insulated screwdriver. The parts still attached to the dial panel are separated. Acetone is used for removing the original paint from the variable capacitor drum. This allows to verify if there is any rust to be taken care of. Having found some tiny dots of rust more or less distributed on the whole surface, some gel rust remover is applied. Then it is washed away using acetone again and later alcohol. At this stage, it is still unclear how the variable capacitor should be connected to its drum. For now, it seems a good idea to solder the drum to the element that would engage with the variable capacitor shaft. However, later that would have to be undone because it turns out that the connection between these parts must be elastic. Various French radios of the early 50s used a particular indicator for showing the selected band, which is identical to the one of this radio. The cord is pulled rotating the shaft of the band selection switch. This cord is now removed and the dial panel is prepared for cleaning it. Like for the drum, acetone is used for removing the original paint. Then, for removing the rust that was developing underneath the paint, the same rust remover gel is applied a few times, and in the end also a metal brush is necessary in some areas. Finally, the residues are removed with alcohol and acetone. The front panel is sprayed with zinc paint and later, but only on the front side, also with an opaque white paint. After removing all the masking tape, it is possible to reinstall the drum. A new screw and a new nut are prepared for connecting the drum to the variable capacitor shaft. This represents the dial cord arrangement for this radio, seen from the rear of the dial panel. Some relatively thick nylon thread cord is used for the dial. The stringing of the band indicator is shown edited, but at normal speed because it is more tricky. After having been washed in the dishwasher and dried, the phenolic parts are cleaned more thoroughly and prepared for being reinstalled on the chassis. Acetone is used for removing the old flux resin residues. A gel rust remover is applied for removing rust and important oxidations in the socket contacts. They are not phenolic parts, but also the pilot light sockets are cleaned from corrosion with the same product. In the end, all the parts are washed with water and a soapy detergent. Then alcohol is used again, and an air blower helps in drying them out. The two potentiometers are cleaned from wire pieces and solder residues. Then only Vaseline oil is used for cleaning the contacts and for stopping further development of rust. No rust remover is used with these components because they are too delicate and something could leak inside, destroying the carbon track. Unfortunately, the power switch that is part of the tone potentiometer is not working. However, it is not advisable to open the potentiometer for fixing it because the body of this model type is made with a cast alloy and the rivets are instead part of that body. Trying to remove them might break the alloy case. Therefore, it is judged safer to put aside the original tone potentiometer for another radio where the switch is not needed and use a new one here. This is the original reverse-engineered schematic diagram of this radio, guessing the tubes that could have been used and outlining the tube types actually used in the restoration. This is the map of components found under the chassis. Like in other projects of this series, there is a written documentation that comes along with the video where diagrams and other important graphics can be observed with better resolution. The power supply of this radio is organized for generating some fixed negative voltages compared to the chassis ground, for biasing the tubes. However, typically in this design, the negative side of the second filter capacitor is connected to the chassis ground. In fact, the chassis was made with two holes for hosting two different filter capacitor cans, and there were signs that both holes had been used originally. Therefore, very likely at a certain point these two filter capacitors were replaced with a single double capacitor can, which obliged to share a common negative terminal. This would also explain the presence or the relatively high value of the capacitor C3 for preventing oscillations or more likely motor boating. During the restoration, the configuration for the power supply is kept in the way in which it arrived, but with the addition of a large electrolytic capacitor for preventing motor boating, a 100 nanofarads capacitor on the B+ line for preventing other oscillations, a resistor in place of the original field coil, which was missing on the unit, one halogen light bulb in series with the B+ line, with the function of current limiter, as well as fuse for protecting the high voltage secondary winding on the power transformer, 6 more halogen light bulbs in parallel with themselves, and in series with the mains for preventing initial current surges and allowing the use of fast fuses rated for 100 milliamps, considering that they would blow only when the current reaches 800 milliamps. Also, germanium diodes were added in parallel with those of the detector tube, just in case the tube lost performance. Considering that an effective field coil, possibly associated with a humbucking coil, is very important for the reduction of the hum reaching the loudspeaker, the missing output transformer is replaced with the type that is appearing in the schematic diagram. In this way, the current flowing on the upper part of the primary winding containing some ripple would counteract and cancel out the hum amplified by the final output tube. The original wave trap used for filtering out from the antenna any signal corresponding to the intermediate frequency is omitted in the new adaptation. In the new schematic diagram, There are also changes in the RF circuit, which will be explained in a later section. The rebuilding process starts populating the chassis with the phenolic parts, which includes sockets and tag strips. They were originally riveted to the chassis, while now small screws are used for the purpose. Also, nylon washers are used for avoiding crashing the phenolic parts. They are not period appropriate, but they are also no more conspicuous than the new screws in place of the rivets. Also, some ground connections are prepared, and a few components that go to ground are already installed. At this stage of the process, it was not known yet that the power switch on the tone control was not working properly. Later, the potentiometer will have to be replaced with a new one. Some more components have already been installed, including the two IF cans. The variable capacitor is going to be installed on the chassis, sitting on 3 grommets. The original ones could still work, but it is judged safer to install a new set. Under the chassis, the variable capacitor is held in place by 3 spring clips. At this point of the reconstruction of the radio, the RF module was not restored yet, as shown in a previous section, but it was already installed still with the original deteriorated mica capacitors. Later in this process of reconstruction, the module will be removed again and properly restored. It is time to build the power supply, starting with the power transformer. A plastic box is prepared for hosting fuses, halogen light bulbs, and later also electrolytic capacitors. When the holes are made, the sockets for the halogen light bulbs are prepared and inserted. All the light bulb sockets are connected in parallel. two fuse holders are inserted in the holes that have been prepared. They are locked in place using superglue to make sure that they would not turn while inserting or removing the fuses. The power cord is inserted inside the chassis and then also inside this box, connecting straight to the fuses. Contrary to the original plan, the safety capacitors for preventing noise are connected right after the fuses. The extension wires connected after the fuses and light bulbs, as well as the extension for the external ground, are braided together. The box is meant to occupy on the chassis the space left by the loudspeaker socket without the need for additional holes on the iron sheet. The power cord is secured to the chassis. The power extensions coming out from the small plastic box are connected to the power transformer and to the chassis ground. A brown wire is braided and used for connecting the power transformer to the power switch. Hot glue is used for keeping the wires tidy along the corner of the chassis. For avoiding confusion with the filament power line, the external ground wire is marked with a piece of green heat shrink pipe. The original power switch is determined to be faulty and unrepairable, so a new tone potentiometer is installed and connected. The two electrolytic filter capacitors are prepared and then inserted in the plastic box that already hosts fuses and light bulb sockets. Also, the capacitor C3 finds its place there. An additional small tag strip is soldered under the chassis. The resistor used in place of the field coil is installed using a dedicated tag strip. Fiberglass tubing is used to ensure the resistor remains isolated from the chassis. Finally, also the socket for the light bulb inserted in series with the B+ line is installed and connected. The power supply is tested with the rectifier tube inserted, and the result is satisfactory. The unit arrived with no loudspeaker and no output transformer. A new 6-inch car loudspeaker is going to be used for the radio, and the candidate new output transformer is tested, together with the speaker, for calculating the impedance at 1 kHz. A piece of plywood is cut to fit in the radio cabinet, and the loudspeaker is installed on top of it together with the selected output transformer. Automotive spade connectors are used for connecting it to the radio chassis. For verifying that what has been done so far to the radio is working, in place of the original RF module, a genuine Geloso component is installed instead, and the IF transformers are aligned accordingly to 467 kHz. The reception is not yet very satisfactory, but it is encouraging at least. Therefore, the original restored RF module is installed and tested. However, now the size of the module is slightly larger, and it is necessary to extend the holes for the trimmers. The radio receives only on narrow intervals of the bands, but the correct value for the intermediate frequency is unknown. Considering that the RF module does not allow to align the antenna section, it is fair to assume that the two sections, oscillator and antenna, do not track. It is explored the possibility to add an additional variable capacitor for fine-tuning the antenna section depending on the band and on the portion of the band. This extra variable capacitor would have to be accessible from the rear. The additional variable capacitor will be put in parallel with the antenna section of the main one. However, it is important to determine the minimum capacity, also including the one added by the coaxial cable chosen for the connection. For compensating the minimum capacity added to the antenna section, a fixed value capacitor is added also to the oscillator section. Under the circumstances, an NP0 component is used. It seems a good idea also the removal of the original trimmers on the main variable capacitor, considering that they would need a different setting depending on the band and on the portion of the band. Some tinfoil is recovered from a can of green beans. It is used for creating a small bracket where the additional variable capacitor could be installed. It works. Later it will be determined that more likely the correct intermediate frequency could be 455 kilohertz. The loudspeaker panel is removed from the cabinet and it will not be reused. Having removed that, it is now also possible to remove the metal frame on the front. This metal frame is made of a very thin iron sheet, which is significantly rusted. It is cleaned first with alcohol, then acetone is used for stripping the residues of the original brown varnish. Then, two different products for rust removal are used until all signs or rust are treated sufficiently well. Off camera, this metal frame is washed with dish soap, dried and then protected using zinc paint first, and then a copper color on top. The structure of the cabinet is damaged and it requires particular attention by adding wood blocks at each corner. In particular, the bottom of the cabinet is reinforced using strong wood, recovered from an old slat bed frame, and on the front side a missing wood strip is also replaced. When all the structural issues have been taken care of, the exterior of the cabinet is cleaned with acetone and steel wool, which also strips a fair amount of the old varnish. Then the exterior and interior of the cabinet is treated with red oil. Because the result is not yet as dark as wanted, also some water-based, wood toner is applied. Finally, some more red oil is applied. Off camera, the cabinet is sprayed with an opaque transparent acrylic paint, and then it is ready for the metal frame, which now has a bright copper color. Installing the dial panel on the chassis is a 3 screws business, which however is not so straightforward, because one of them is exactly above the space occupied by the REF module. This panel was probably meant to be installed on the chassis before anything else, and then never removed again. In this case, the RF module had to be released in order to be able to insert the screw from under the chassis. As already described in a previous section, the piece of the dial mechanism that is inserted on the variable capacitor shaft was soldered to the drum, but that was a mistake, because now the variable capacitor is subjected to severe mechanical stress, way beyond the purpose of the grommets on which it is installed. Therefore, this piece had to be desoldered and connected instead using something sufficiently elastic, like these 2 grommets. The dial indicator lost its original red color. Instead of repainting, some red Heath shrink pipe is used around it. The band indicator has its own cord driven by a bush inserted on the band selector shaft. Luckily, the original set screw for this bush is metric, and it can be replaced. two small brackets are used to hold the dial glass on the dial panel. They have signs of rust and deserve some treatment. This is the occasion for testing a homemade rust remover gel. It is not as fast as other commercial products, but it works. Each one of these two brackets is held in place by a screw whose thread seems compatible with the standard 4-40 UNC. The newly printed dial glass is prepared, removing the protective film along the edges. It is then inserted and fixed on the dial panel, paying attention to the alignment of the two round windows for the Magic Eye tube and the band indicator. Finally, it is time to put the Magic Eye tube. This is not the original one, which was completely dark, but something that still has a glimpse of life. During the restoration, the IF transformers underwent various alignments at different frequencies. In the end, they have been set to 455 kHz, which showed a slight improvement in the tracking between oscillator and antenna section. Even though changing band, it is still necessary to adjust the antenna tuning operating the additional variable capacitor on the rear. For the alignment procedure that is visible in these clips, the signal generator was set for sweeping between 445 and 465 kHz. The signal was injected using a dummy antenna first to the control grid of the IF amplifier tube, then to the grid of the mixer converter tube. The intensity of the signal was read at the same point where the Magic Eye tube would have done it, seeking for the most negative values. Before putting the chassis back in the cabinet, there are still a couple of things to take care of. The new tone potentiometer does not have a sufficiently long shaft. A scrap piece of iron of the right diameter is recovered for the purpose and used for making a shaft extension. For connecting it, a 6 mm diameter D9L20 shaft coupler is used. The grill cloth should have been prepared before, but it was forgotten. The floral pattern already chosen in other projects seems adequate also for this radio. The soldering iron is used for opening the holes for the screws through the cloth. Here is a last view under and above the chassis. The coil formerly used for the wave trap has been kept in its original place for memory, but not connected. Here are the parts that have been discarded during the restoration. They will be kept, but not in the way that was done until the previous restoration project of this series because of space constraints. Anyhow, in preserving the story of an item Also, the details about the discarded components matter, especially when they are not restuffed like in this restoration. Here is the reproduction of the labels and printings around the capacitors. The labels that were possible to detach were also kept and scanned. The chassis goes back in the cabinet. The protective film of the new dial glass is peeled a little bit more to make sure that it would not remain stuck behind the metal frame. The chassis is fixed to the cabinet with 2 screws. The set composed by loudspeaker and output transformer is connected to the chassis. The back panel needs a hole for allowing access to the additional variable capacitor responsible for the antenna tuning. Some black heat shrink pipe is used to cover the variable capacitor shaft so that it would look like a small knob. The back panel is installed, and later a warning label is added on top. The radio is meant to be used, therefore it is important to remind some basic safety rules. This radio arrived with unmatching knobs. Initially, it is considered the option of making knobs with a piece of wood. A cup saw is used here to cut suitable cylinders. Unfortunately, the right size for the cup saw is not available, therefore these cylinders are cut larger than the optimal diameter. A hole is necessary for the set screw. The diameter should be ½ millimeter less than the thread of the set screw. Wood stain is applied with the hope to make these knobs dark brown. Unfortunately, the result is not satisfactory, therefore they are sprayed with a very dark brown acrylic color, which feels even worse. The set screws are inserted. Having observed that the aesthetic result on the radio is just disgusting, hoping to do better this way, some fabric with the same pattern of the grill cloth is glued on the front of these new knobs. Well, the result is funny, to say the least. For this restoration, it seems safer using new equipment knobs type MFA05, sprayed with an opaque black paint. If possible, I would like to preserve the story of the radios that I restore, and if nothing else is available, I am happy if at least I can put the list of the previous owners in the cabinet. This radio may have been bought in Egypt because of the dial scale. Anyhow, it was owned originally by a family living in the village Le Puy in the commune Vedela, Department Creuse, France. Every time that a new band is selected, it is better to align the antenna. However, even with a proper antenna alignment, the radio has an unsatisfactory sensitivity. Therefore, almost a year later, it returns on the bench for installing an antenna preamplifier. The antenna preamplifier is based on an NPN transistor, made for television, capable of working with relatively high voltages, so that it can be powered with the B+ line. The project is built on a common prototype board and installed under the chassis, connecting it between the antenna and the RF module. The shielded cable for the input connection is mandatory. The magic eye of this radio is spent. Therefore, an experimental simple solid-state replacement is made, like the schematic diagram shows. The green LVDs are connected in parallel using a separate piece of prototype board. Some of the posts have been drilled out to avoid involuntary shorts while connecting the LEDs together. The original Magic Eye tube was an EM4, which has a side contact base. Therefore, the same type of base, obtained from a broken tube, is used for installing the new Magic Eye.
جمهوری اسلامی تنگه هرمز
The test is done in the late evening, starting with the short wave and ending with the long wave band. Every time that a band is selected, it is necessary to adjust the antenna, and sometimes it is useful to do that also while tuning in different parts of the same band.
Conjonction des sanctions américaines et des difficultés économiques. Le président russe Vladimir Poutine a
Kazakhstan. 寄包裹去香港多长时间能到？
decades ago. Et que Téhéran
y desde distintas perspectivas.
increase this new electric model, different AI-powered service.
La preservación cultural enfrenta desafíos y qué prácticas hoy han sido efectivos para from a lot of functions, some of our ways in collaborating.
того, щоб посилити роль на міжнародній арені і учасниці ігорних сторони, але Україна, яка впливає на майбутній формат і я там більш детально можу потім розказати на церемонії, щоб були.
Nasadil kolen bak gidiyorsan oyen taktak. Şesin zamru nara ya mafet alamava. Ya işliğin istifat.
Senin namazı sarı ne İran'ı Hollanda sarı kokuyor. Habiba lama dua wasiwa boleh lama dia. Ini ada lucu lucu mana deh. Haji cuma untuk iklan semua.
Directo, uno de los árbitros, que ha habido parte de los árbitros españoles, ha dicho.
Radio Koper.
الذي قام الكيان باغتصاب الأراضي الفلسطينية واحتلالها
Unfortunately, in the long wave band, nothing can be received.